Hello and welcome to another Retropower Uncut. And this week's slightly different. We've decided that there's a lot of bits and bobs going on this week, and a lot of things that aren't that photogenic. So we decided to do something a little bit different. We've decided to do a little walkthrough of some of the machinery we use in the day-to-day goings on here, and just show you what processes happen here and where things start and where things move on through when we're talking about metalwork here. We'll focus on metalwork. Obviously, there's less machinery involved in the other processes here, but it'd be quite interesting, I thought, for folks to see what we use and what we do on a day-to-day basis, particularly in the fabrication workshop. So obviously, when we start work on a body shell, there's usually a lot of new metal involved in one way or another. We either add a lot of metal or we cut a lot out and change a lot of it to different bits of metal. So the start point, I guess, when we look at that is that we start with a piece of metal. So here we have a pile of bits of sheet steel, which we then are going to do various bits of work with. One of the early stages in that process, I guess, after we've done any drawings needed or any working out of shapes, plans, patterns, that sort of thing. We won't go into all that right now, because that doesn't involve the machinery. But once we know what we've got to, what shapes we've got to make, we then work out how we're going to make them. And one of the first parts of the process is obviously going to be cutting that material to shape. So, pretty important bit of kit behind me, a guillotine. Very old. I can't actually even remember what make this is. I was going to say it's a Morgan. I'm not actually completely sure. I did know and I've forgotten. I've had it that long. Good old machine. Keeps on going. It's due a blade change next week. We're going to turn and reset the blade on that next week. One of the joyous tasks. It takes ages to do. It's a right pain, but we're going to do that. Stuart and Adam are going to do a blade swap on that next week, so we can reset that, because we're getting a few burrs on cut edges, and it's starting to annoy us all. So it's overdue. We normally do it every sort of year and a half to 2 years. It's overdue. So we're going to do that anyway. So yeah. So following that, we've cut our bit of metal up. There are other ways of cutting things up though as well here. That's probably the most used way when it comes to a sheet steel. But let's go and have a quick look at another alternative way. The process we did use on most sort of brackets and the like until about 3 years ago. This is a 1930s speed axe bandsaw, one of the oldest. In fact, it's possibly the oldest bit of equipment we own. It's a beautifully made machine. We gave it a sort of light restoration, not that it needed a lot really. I didn't pay a lot for it, salvaged it from the back of some old horse stables. It's a great bit of kit. All the body on it is cast aluminium, strangely. That's all cast aluminium, but then the base and the guard are ludicrously heavy. They're cast iron. It's really like over half-inch thick cast iron, the belt guard on it. Incredibly well-built machine. Just a lovely machine. We use that a lot for cutting bits, one-off brackets where it's not worth drawing them on CAD. Obviously, a lot of stuff now we draw on CAD, and I'll explain what we do with that in a minute. But on the smaller parts where there's just no point drawing them. By the time you've drawn them, it's as quick to make them from scratch anyway. We tend to cut the parts out on that. You know, we use a drill. We'll initially guillotine the rough piece. We'll then drill some holes in it, whatever. Then we'll do the final cuts on the bandsaw. That's great. It's a brilliant bit of kit for that. Lovely old machine. I do like old, heavy, well-built machinery, as you'll see as we walk around. But moving on, most bracketry and most parts we make now that aren't the bigger sheet metal parts, the smaller fabrications, we generally draw most of them on CAD now. It tends to be faster than doing pencil sketches and layouts by hand on the steel. We tend to draw on CAD now, and the big move forward was 3 years ago there. If we walk this way, the big move forward was to get the CNC plasma table, which is through here. It's an 8 foot by 4 foot machine, so we can put full sheets on it. We don't tend to buy 8 by 4 sheets. They're a bit of a pain to handle, and we can't, if we do need to guillotine them, the guillotine is only a 4 foot blade. That wouldn't be a problem, you would think, apart from the fact that the guillotine is an imperial 4 foot blade, and the sheets, 8 foot by 4 foot sheets these days tend to be 1250 wide, not 1220, so they don't actually fully cut on the guillotine. So anyway, that's an aside. We tend to buy 2 metre by 1 metre sheets anyway. But yeah, this machine's cut, I couldn't even count the number of parts that this has cut since we've had it. Many thousands of parts. I had a look the other day, and I think we were on 1,100 drawings that it's cut. but obviously a number of those will have been multiple parts per drawing. So many thousands of parts this has cut now. The bed slats have been changed twice in it. It's done a lot of parts in the last 3 years that we've owned it. As you can see, the heavy end of the sort of things it'll cut, or heavier end, that's 10mm plate that's on there for, I was modifying a machine, which we'll talk about in a bit actually, but I was making some parts for a machine using that, and then the other two pieces that were cut out of that piece of 10mm plate were the axle end plates actually for the Utah axle caliper brackets. So it's good for that, but then we cut 1mm sheet on it, we'll cut 1.2, 1.6, 2mm, 3mm, you cut everything, all sorts of parts on this. Most brackets we make are now cut on the plasma table, hence why you'll have probably seen lots of little bits of footage of it, but we use this endlessly. Really wouldn't want to be without it now. So brilliant bit of kit. As I'm walking back past, I'll just touch on that, nothing to do with cutting metal, but equally useful bit of kit that we've owned for a similar length of time to the plasma table is a 3D printer. It's a Creality machine, CR10 S4 I think the model, but I've completely rebuilt it. It's now a direct drive extruder. I've thrown most of it away basically, other than the frame, and completely changed the extruder. It's a UK made hot end on it now. I've forgotten the make now. E3D V6 hot end on it, with a drive motor built onto it. Basically, it's a Bondtech extruder, and the motor's on the carriage now. It's just a nicer layout than the machine used to be. It needs a rewire really. With the next stage on that, the next week, we're going to redo the wiring on it. Because that was a bit of a cobble up 3 years ago when I was first getting the machine up and running and getting it to work how we wanted it to work, and it now needs redoing really because it's a bit of a lash up. So we're going to do that next week. But yeah, that's just another thing in passing. I'll walk this way, back out here. We'll go around, and so we've sort of talked about cutting the steel up now. So at this stage we've kind of got a lump of steel. It would probably need finishing. Obviously, we'll tidy up edges with angle grinders. We'll use a belt linisher to tidy edges up. The various things we'd use to clean up edges and prep for further work. But following that, we'd need to do some form of shaping. So if I wander this way, just try and keep Jamie on his toes, walking backwards and forwards. I guess the simplest piece of shaping that you're likely to be doing at any point is folding, which is a pretty frequent task. This was the first folder we ever bought, an old Morgan straight folder, nothing very fancy at all, but it does the job. We've now got a radius bar permanently on that. It's a 20mm radius bar permanently on it. We use that for, obviously, radius folds like that, and you find you can bump a corner round. You can do multiple folds carefully to create a larger radius than the actual bar that's in the machine. So we use that a bit. It's not day in, day out, but we use it a bit. And we use it little enough that it's worth keeping the radius bar in it. We've still got the straight fold bar, but we tend to keep the radius one in. We've got this little Chinese former, which is handy. It's a little removable finger folder. It's quite handy for making little folded brackets. It's not very heavy duty. You know, it'll fold very narrow pieces of 16 gauge. That's about the top end of what that'll fold. The guillotine on it's next to useless, if I'm honest. You can cut paper with it, but that's about it. The rolls are okay for rolling very, very light, very, very small pieces, but it's quite handy for rolling little cylinders, little cones, little small fabrications. It's quite handy for that, which is why we keep it. That's all that's particularly useful for, really, but I wouldn't want to get rid of it because it has its uses on small fabrications. The real bread and butter of the fabrication of the folding trade here is Kerry Ketona, as she's been christened. is this Ketona. It's basically, you may be familiar with a machine called a Ketona Hydroform. I don't know what Ketona called these, but they make a machine called a Hydroform, which works in exactly the same way. It has a clamping blade that comes down from the top, which is this piece of safety wood in there. We always keep that in, so it keeps the clamp handles out of the way, and also means that finger trap's not there. These clamp blades come down, they're removable, they're segmented, so you can fold different widths. And the blade, it folds from both sides simultaneously. I'll give you a quick demonstration. If I open that up, there's that now. It folds from both sides simultaneously. So this side, that's now roughly at 90 degrees fold. It'll fold way past 90 degrees, and it folds. The folding blades on it are of that depth. but then this angle is removable, and it's also invertible so you can fold with a roughly 3/4 inch blade, or you can take that off and it will fold 3/8. When it's at 3/8, it means you can put steps at 3/8 of an inch intervals along a sheet. It's actually very nimble. You can fold a lot of different things with this folder. It's quite a nice bit of kit for folding a whole variety of parts that we do. Wouldn't want to be without that. That was a very, very useful bit of machinery to buy that. Further, just nipping round this corner while we're talking about the initial bits of shaping, another useful bit of kit. Bought from, I'll name drop him now, Matt at Stakesy's. We try and use Stakesy quite a lot. Matt Stakes, a really good guy. We buy quite a lot of little bits and bobs from him. It varies really, but we bought quite a few things on him over a period of time. He set up his business at almost the same time as we set up ours. And it's been quite nice for both of us to grow our businesses together, and it's been nice to work with him. He's a really good guy, so for metalwork machinery, make him your first call at Stakesy's. Little name drop there for him, but he's a really good guy to deal with. But yeah, he imported these JD squared bead rollers for quite a long time. He's actually stopped doing them. He's doing his own bead roller now, but it'll be a similar type of design. But yeah, Matt, we got that from Matt at Stakesy's. That's a really good bead roller. We've got quite a lot of different sets of rolls for that. That's a flat set that's in there at the minute. We've got set of tipping rolls, set of tank rolls, step rolls, whole variety of some wire edge rolls. We've got a variety of rolls for that. We've got a number of other rollers. I'll put that down there. We've got this little really old Edwards Jenny, which we use for doing little wire edge jobs. It's just handy because we can leave a little wiring roll in it, and then this comes. I'm not going to get it out now because it's stuck. We've got this stand dolly which we made out of an old wheel, and we use that for a whole variety of things. Again, really useful bit of kit. But this will go into there for doing little Jenny rolling jobs. We've got another roller over there. I won't even go in. We've got another old one over there which we use for various things. This is handy for knocking parts, just for shaping parts on with a hammer. It's basically just a stand anvil, which is useful for just shaping little sheet metal parts. We use it quite a lot for just finishing parts that have been shaped elsewhere. And it's a useful way of locating various rollers and jennies and things on something that you can move around the workshop relatively easily, but it's heavy enough that it doesn't move around too much while you're using it. I'll just put that out of there carefully. You take stake anvils in there, so we can use that to do a variety of work fairly readily. We make various things as we need them. I mean, we've got a bit of an old farm bale spike that we've shaped, that Stu's shaped for knocking edges over on. Any amount of things that you make from bits of metal in order to form a particular shape, you end up making parts all the time for that. And on that note, we'll flit around the corner here, and I'll walk around to the other side of the camera. If Jamie just comes around here a little bit so we get this side of the machine, this is what a lot of the industry would refer to as a Pullmax. The Americans refer to these as a Pullmax, and that's because the leading brand of these particular machines was originally the Swedish Pullmax company. This is a Henry Pell's machine, British made. Very old, 1946, I think, this was made. And they were originally sheet metal nibblers. They were basically designed for cutting circles out of sheet. It's got a big throat depth, that's the cutting point. Originally it would have just had a punch and an anvil there, and it would have been used for nibbling circles out up to yay diameter, twice that as diameter, that radius. And it would have been used for cutting circles. Nowadays, they tend not to be used for that because we've got a CNC plasma or a laser for that job. So what we use them for now is for putting various forms in bits of sheet metal. Similar job to the bead roller, but there are various reasons why this can be better. It'll handle much heavier steel sections than the bead roller. You know, you can form 2mm thick steel fairly readily on this if you need to. And what we do is we just make the die sets for this according to what we need. So if we have a floor pan we need to make with a particular fluting in it, a particular section in it, then we can just make a set of dies very easily, like so, which we'll just cut, we'll just bandsaw and fettle from a piece of steel plate. We'll just TIG weld them onto some 5/8 stubs, 5/8 inch steel stubs, and they go into a pair of milling chucks that are fitted to the machine. and they mean that we can form all sorts of shapes in floor pans, all sorts of beads and edges and a whole variety of things. You know, it comes up to, we can do quite complicated sections with it if we need to. I mean, we've done all sorts of stepped pieces like that, which I think that was part of an NSU sill. It was done a long time ago now, but the variety is endless of the parts you can make on this. We use it for that. We also use it for edge tipping, where we can't get in with a tipping roll for some reason. We use this, which is I've just TIG brazed a hardened piece. It's actually just a piece of an old lathe tool shank onto there, and with a flat anvil on there and an edge guide, so we can actually we can create a tipped edge around any variety of shape with it. So it's quite handy for that. And we've got a big roller track guide here. I won't bother getting it out, but we've got a big roller track guide there that we can bolt onto the machine, and then we can clamp pieces of sheet metal to it and do repeated parallel swages, flutes, steps, whatever you want to do. We can do that using that roller track guide, which has got about 1.6 meters, I think, of travel on it. We've used that a lot on things like Kaiser 2. And you see the floor pans in that, they're all beaded all the way along with parallel beads. Well, they were all done on this machine. All those beads are put in on this. We use it for tipping wheel arch edges, sometimes wire edging panels, putting the wire groove on the edges of panels, but mainly beading and putting flutes and steps into things. But as I say, the possibilities are endless, really. There's another example. That's a standard. That's hardened actually, that one, but that's a beading die for just putting simple beads into parts. It doesn't look an awful lot, but it just enables you to put beads into floor pans and things sometimes where it's just more awkward to do with a bead roller. It's easier to do with the Pullmax, and as I say, it will also easily put a bead with that tool. It'll put that into 2mm thick steel without too much difficulty at all. So really useful bit of equipment that. We wouldn't want to be without that. One of the funny things with this machine is, despite its 1946 age, I actually found an address for Henry Pell's company, rang them up, lovely guy answered the phone, and they supplied me a manual for the machine, which they don't make the machines anymore, but they still make the tooling for them. And yeah, he supplied me a manual for the machine from the 40s. It's pretty impressive, really. Proper old British company that are still sort of going. And yeah, it's quite nice, quite heartening to have a phone call like that. And so that's one side. That's sort of hard forming. We'll probably move on now to valves. I'll swing by this way. It's trying to decide what to do next. I'll swing by, I'll walk over here. I'll let Jamie film from a distance a little bit, but we also have this Sweeney and Bloxage. It's a deep throat fly press. Can't remember the throat depth on it. It's got to be about 16 inches, something like that. That's a really good bit of equipment for press forming things. A little idea I'm almost inordinately proud of that's linked to the fly press was going back to the Morris, the little Morris logo that we pressed into the bulkhead on the Morris Minor. Is our way of making the tools for doing those embossings. We CNC cut them from sheet steel on the CNC plasma, and then that gives us the two halves of a tool to make an embossing in steel sheet. The problem is that you need to be able to align the halves of those tools very accurately, and conventionally that would be done using pins on a press platen, which is quite an expensive, complicated, time-consuming way of doing it to make it universal for anything that you might want to emboss. It's doable, but it can become quite a convoluted task. And when you're only doing one or two embossings using that particular tool, you really want a really quick and easy way of doing it. And this is a handy tip for anybody that wants to do this, because it's such a simple thing. You basically just make a bottom platen that's really heavy so it doesn't move, leave that on the bottom of the press, have a top platen that you just put in the top of the press, nothing technical at all, you just fit it to the top of the press. Get your two pieces of your tool, lay them together on the bottom platen, make sure they're aligned, then take the outer one off, or the inner one, take one of them off, mix up some 5-minute quick araldite, quick epoxy, put it on it, realign it, stick it on, and then put some of the same quick epoxy onto the other half of the top half of the other part of the tool, shut the press onto it, let the epoxy go off, and you can open it, do your pressings, nothing moves, so it's there for the two times you need to do the pressing, or however many handful of pressings you need to make. And when you're done, just tap them off with a chisel, and you've got a blank platen, and you can do another one. And the chances are that's probably the only time you're ever going to use the tool. So it's a really simple way of doing it. You just glue the halves to the tool, do the pressing, and then tip them off with a chisel. Really simple way of making little embossed parts on a fly press. But yeah, we also use it for folding sections, doing other little bits and bobs. And pressing on bearings and all sorts of things, bending heavy bits of bar. It's a tool you want to be. We've got a louver tool for it as well, so we can louver panels up to yay deep into the panel. You know, very useful bit of kit. Wouldn't want to be without it. Punching and swaging, doing reinforcers to go around roll cage tubes and all that sort of stuff. You know, we swage holes to go around those. We've got a set of hole punches for it. Obviously we CNC a lot of the holes now, but for various panels we can punch and swage holes into them with it. Just endless uses. Once you've got it, you wonder how you manage without. We'll go this way. We'll wander on this way, past a couple of other random bits of machinery. Tube bender, again came via Statesies, via Matic Statesies. Useful bit of kit. We don't do that much tube work, but again, the tube work that we do, the roll cages that we make in-house, and the cooling system, plumbing and all that sort of stuff that we do, invaluable, really wouldn't want to be without it. Cold saw, old Met Brown 3-inch cut cold saw. Again, you struggle without it really, invaluable machine. Another little innovation, it's incredibly simple, but you wonder why people don't do it like that. I've seen a few modifications for hydraulic presses, cheap Chinese-made hydraulic presses, that have a blade, a folding blade on the top, on the ram on the top, and a V-form tool on the bottom, which is great, but you can't fold very far around before you collide with the ram. And it struck me that a really simple way of dealing with this is to put the V-form on the top and put the blade or whatever on the bottom, and then you can fold around the beam. So I cut these bits out of some 1/2-inch plate, and what we do is we can put a radius piece of bar of varying diameters on the bottom, and then we can fold a radius fold, and we can go all the way around, so we can make round cornered tanks without needing to use tank rolls and the time consumption that happens with using tank rolls and a bead roller. We can just fold corners of a radius cornered tank all the way around this. It's just a nice way, and we can change that bar to different diameters and fold all different manner of radiuses. So it's just another use. Obviously we use it as a bearing press as well, but it's really handy for folding a variety of diameters. Then wandering on a little bit further around the corner, we come to these two bits of kit. Actually in the background, off on a tangent again, two other things, two sets of plate rolls in the background. We've got really big heavy plate rolls which will roll anything that you could want to roll far heavier than on a car, but obviously to a bigger diameter. But you roll 1/4-inch plate in those, no problem at all. And we've got a smaller set here, which are probably the ones we use the most. Again, in single curvature, we make all our sort of rolling cones, transmission tunnels typically. If you think of transmission tunnels in a lot of cars, we roll a lot of those on these, and the bell housing part of transmission tunnels, again, rolling the cones for those, roll those on that. But again, then going to compound curvature work, I'll let Jamie reverse up probably, or do you want to come this side? Yeah, we'll go that way. Coming to compound curvature work, this is the main area of that people would be familiar with for that is the English wheel. American-made English wheel in this particular case. It's the most used piece of equipment probably in the UK for making compound curvature panels. As a bit of sort of background to that, an English wheel only does one job. Okay, there are a variety of other things you can use it for, but it's designed to do only one job. People talk about, there's an awful lot of videos spouting all sorts of rubbish that I've read online, that I've watched online, but the simple fact is, all it does is stretch metal. It's basically a rolling hammer. It stretches metal. There are a variety of anvil wheels that can be fitted, ranging from the flat one that's in now to a really tight radius. I can't remember what radius it is, but a really tight radius such as that. All that does is give you clearance on the material that you've rolled. So on that one, obviously, if you roll a piece of material through that, it'll spread it in all directions, but it's still flat. So the curvature that forms as you roll that material in there will quickly catch the corners of the roll. With this one in there, it won't. It can follow round, and as you roll the material and it spreads and curves, it will follow that the radius of the roll around. The principle is that you squeeze the material, it grows. If you don't squeeze the material all the way to the edges of the panel, then the material has to go somewhere, so the panel grows upwards or downwards and forms a compound curve. So that's just simply stretching material. So we use that a lot for forming compound curvature panels, again referring to the Morris as being near to us. We will be using it very shortly for doing a lot of deforming work in forming the compound curves on the panels on the Morris. The only caveat to that is that there's a limitation on how far you can shape a panel with that, due to the thinning of the material. Obviously, as you stretch the material, it gets thinner, and you can only thin that material so far before you can go no further, before it becomes too thin to be useful. So the solution to that is to shrink material around the edges of the panel, so you combine the stretching effect of the wheel in the middle and the shrinking effect around the edge to mean that you don't have to stretch the middle so far and you don't thin the material as much. And traditionally, the way you would start roughing out a panel, once you've patterned it and generated the initial outline of the panel and cut it in your steel blank, you would use a stump, which we use a lot, which is here. We've got a piece of, I think it's an oak stump. It's a piece of old tree anyway, which we've got a pin going. It moves, but it's got a pin through the middle of it into the floor, so it doesn't bugger off all around the workshop. And what you can do on this stump is combine stretching and shrinking at the same time. It's a pretty common operation. There's plenty of videos of people doing it far better, so I'm not going to try and demonstrate it now. Ray Shalene has posted some really good videos on YouTube of how to use a stump and what the purpose is. But basically, you trap the material in the dish of this, you strike it, it forms a ripple on the material on the corner of there. You then flatten that ripple on the side of the stump, trap it, flatten it out, and then form another ripple. At that point, you stretch the middle of the piece you're striking with the ball nose of the hammer, and you ripple the side, and then flattening the ripple out causes that to shrink. So you're combining the stretching in the middle, the shrinking on the outside, and that starts to form the dish in the panel that you're trying to shape in 2 dimensions. Sorry, in 3, the compound curvature of the panel. You can do that simultaneously on the stump. I mean, that's a hammer that we've knocked up. It's a Thor replaceable face nylon hammer, where we've just put a bullet nose. We've machined just a nylon bullet nose for that side, which is very good for that purpose. It's a very good stump. It's a 4-pound hammer. So you can exert a lot of force with that. That's the other Tinman's blocking hammer that we've got, which I don't quite know where I got that one from. I think it was off eBay a long time ago. But anyway, that's another real weighty blocking hammer, really useful for this job. Another very quick aside at this point is the other. We've got a large caster wheel, a polyurethane tired caster wheel that we use on the English wheel sometimes. This changes it from being a stretching machine to a bending machine. Basically makes it do the job that the bending rolls do. However, it means that you can bend in places that you can't bend with the bending rolls. This basically enables you to vary a bend much more easily than you can in the bending rolls, and it enables you to be able to put a bend around a corner. Now that starts to get a bit complicated, because obviously there is then compound curvature involved, and I won't go into all that, but it enables you to basically do the job of the rolls around the corner should you need to. Also, we use that quite a lot actually. I say it's not wheeling at that point, it's bending. But it is quite a useful little caster roll that we use in here. I've touched on the talking about shrinking using the stump there. If we move around the corner, I can just show you the other alternatives we've got on that, which are we've got a variety of shrinker and stretching machines. We've got 2 of these little 5-inch throat, or 6, might be 6-inch throat, I can't remember now, deep throat shrinkers. Again, from Stakesy's, really good machines. That's got the shrink jaws in it. We've got another one just around the corner with stretch jaws in it. These are very simple. I shouldn't really operate it without a bit of metal in it. But as you push the pedal down, the jaws squeeze or operate on ramps. As they strike each other, they then close and push together, and it shrinks the edge of the panel. You generally use these for shrinking flanges around windscreen apertures, for shaping flanges around apertures on a car body, or for tweaking the edges of panels to take twists out of them, that sort of thing. And for rectification, after you put beads in panels, you might need to straighten them out, because they tend to, the bead roller will tend to stretch parts of the panel, and you may need to shrink them back, or make alterations to a panel after you've done some other forming operations on it. They're great for that. They probably don't generally have the power for the initial pulling of the edges of a really big panel, like a complete wing. When you're trying to shape a complete wing, to pull the edges in before you start wheeling it, you really need more power than that, which is where you'd use the stump. However, doing a lot of panels repetitively, particularly when you might not be as young as you used to be, is pretty hard work on the arms on the stump. So that's the latest bit of kit we've now bought. Was this shrinker, which I've just finished doing some modifications to, putting a large air cylinder on it. The manufacturer of this machine offers two variants. They offer a pedal operated, which this was, and a hydraulically operated, but the actual nuts and bolts of the machine are the same. It's just that one has a hydraulic cylinder on and one doesn't. The pedal operated one doesn't really have enough power for the job we wanted, and it's pretty hard work. So we've put a big air cylinder on it now, and now using this, we can shrink a good number of inches into the sides of an 18 gauge panel, which is the type of thickness we tend to start with for something like a wing on a car. We tend to start with 18 gauge ideally on that. That gives you enough thickness to play with in the centre of the wing, where there's a lot of crown got to be raised on the wheel, but it's still a thickness that you can work to a good extent on a shrinker and the wheel. It just gives you the flexibility of panel thickness. And then with this machine, I can pull the edges of that panel in before we start wheeling it. The alternative is you can do all the work on the wheel, but you then need to make the panel in a number of pieces, because you hit that limitation of how far you can stretch the material in the middle. With this, I can pull the edges in first, then start the wheeling. So I can shrink the edges, then start the wheeling, and it means that we can make the panel in less parts, which just means that there's less finishing required on the final panel, because the weld finishing is quite time consuming. The planishing and panel beating of all the welds is quite a time consuming operation. And then moving on, obviously touching on the welding then, when we make the panels in any of these operations, we've then got to weld them together and weld them into a body shell. So moving on, I'm going to head this way again. We've got a couple of the most used bits of kit here, which are the spot welders. We've got two of those. We've got that one, which is generally used with the gun for doing spot welding. We've got another one which we use for pin pulling and stud welding and that side of things, so that we don't have to completely unset and reset the machines all the time. That's used a hell of a lot on general fabrication around here. There's a lot of spot welding carried out, so they're a regular used machine. And then this is one of the MIG welders we've got. We've got a little single phase one behind here, which I've had for many years. I bought that prior to us setting up Retropower, so we've had that a long time. I've had that a long time. It's done a lot of years service, that one. Then we've got this big ESAB. This is way overkill for sheet metal work, but it's actually a really good bit of kit. It's a remote feeder machine. It's got a four-wheel drive unit, wire drive unit in it, which is just bomb-proof. Really good bit of kit. It's 400 amp output, water cooler on it, so it can take a water-cooled torch, which we've got, although it's not on at the minute. So you can weld, welding half. We don't do it very often on cars, but modifying, making bits of machinery that we do quite regularly is very handy to be able to weld 10 mil plus thickness steel, and this does that with no problem at all. I can weld half-inch plate with no issues at all with that. It's not even stretching, it's not even breaking a sweat. So that's a really handy bit of kit for the heavy end stuff. But equally, it's got really good wire control down at, you can be welding at 20 amps with that, and it's got really good control at that as well. And then moving on, probably the most used bit of welding equipment running over this way is my little baby here, which is the Hitachi TIG. It's a 300 amp dual inverter machine. Absolutely brilliant piece of kit. I'm sure there are better welders out there now, but there are hell of a lot more money than I paid for this one. And this, any issues with any welds I do now, or that any of us do now, are us, not this. It's an inverter pair machine. It's got a mixed TIG function on it, which is handy. There are various other alternatives to that on the more modern machines. But on this, it has the ability to run as an AC and DC simultaneous machine for welding really heavy aluminium. So that's a function that's just so useful on really heavy aluminium work. But at the same time, it will weld happily at 10 amps DC. So you can weld, you can do the old razor blade to razor blade trick with it. It's an incredibly versatile machine. Water-cooled torch. I use a WP9 torch on the machine. It's snotty and old because it gets used every day. It's wrapped in insulating tape because that's the easiest way to hold a trigger onto it. And I'm sure there are better torches out there, and I'll get a lot of lectures on all sorts of wonderful things. But I love a little WP9 torch. When you put short consumables on it, you can get in all sorts of corners. Nice suede cover, really ultra flexible cooling pipes inside it. And with the water cooling, the conductor to the torch is super flexible, so you can get it right in corners. It's a really small torch, just brilliant. I wouldn't swap that for anything. Trying to think what other things. Most of the functions on the machine are brilliant. It's got all the usual upslope, downslope timing. Obviously after gas. It's got this pendant control, which when you're welding a roll cage inside a car, that's brilliant. That comes off and can go inside the car with you. So if you're working on pulse, you've got your max and your minimum current for pulse, which you can set, and you can just set your weld current from inside the car there. Obviously, you could have an on-torch control. I haven't got one, but you don't really need it with this. You can take this and you've got the full range from 0 to 300 amps at your hand wherever you're working. It's got foot pedal control, which is floating around behind me for when we're working at the bench. We've got the foot pedal control as well. I don't think I need any more TIG machine than that. I can't really sing the praises of that machine enough. It's an absolutely looks a strange old thing to how it looks like I've got a PC sat in the workshop, but it's an absolutely brilliant bit of kit, that, and I wouldn't swap it for anything, I don't think. Although, if somebody wants to give me a brand new Fronius for free or something, then fine, but I don't think I'd swap that for anything. It's a superb bit of equipment. And I think, here's another one, right behind me now. This, probably another rather valuable bit of equipment in the workshop. The marking out table, welding table, is basically a bit of flat cast iron that we use for most jobs. It's not a surface table, it's not calibrated, it's nothing too fancy, but it is pretty flat, and it's cast iron and it doesn't move because it's nearly 6 inches thick, I think. It's extremely heavy, although it is hollow. If anybody knows what it originated as, I'd be interested to know, because it's had water piped through it, and it would be able to bolt up to something, and it's had water piped through it. I suspect it was either heated or cooled. My gut feel is it was some sort of press cutting table for possibly working with rubber on, and it was water heated or water cooled, I'm not quite sure which, possibly water cooled, and it was used for press cutting rubber, possibly shoe. We've got a big shoe industry in this area, and I suspect it might have been for cutting out, for clicking press, cutting soles for shoes on, possibly something like that. I don't really know, off on a wild tangent, but it's got some origin that isn't what I'm doing with it. But it's a really useful, really nice, heavy, flat table for working on that we use for welding. We've got all bits of kit that you invent along the way. We've got this, I made up this little, we plate magnet it down to the table, we can drag it round, reset the plate magnet wherever you want it to be, and you've got then an armrest for when you're TIG welding. Really useful thing. You can slide your arm along it with the TIG torch for welding corners of tanks. You can prop things up on it. Just a really handy way of working. It's got all that. You can put that on there. That's a slider if you're not happy with how your glove's sliding on there. You can use that sleeve to slide it on. Just a useful way of propping things up and aligning things. And just a handy bit of kit to have, really. I think at that point I'll stop waffling, but we've done a reasonable tour of what most of the fabrication kit is in the Retropower workshop. So I shall see you again soon.